In example 4, we're going to be putting our new calculator skills to use and working to determine when we should be using binomial PDF versus binomial CDF. So in this case, we've got some trials of Zyrtec, and in those trials, 14% of them experienced drowsiness. We contact 30 Zyrtec users at random and ask them if they have experienced drowsiness while using the product. And we're going to calculate the probabilities that we find the following. Okay, so what is the probability that 5 people have experienced drowsiness? So first thing, let's make sure we've got a binomial situation. Okay, yes, we do have a success or failure, drowsy or not. Okay, we have independent trials and repeated, 30 of them, and independent because what one Zyrtec user has happened has no bearing on another. Okay, so we should be doing that. So we are finding the probability that 5 people have experienced drowsiness. So we are looking for the probability that X is 5. Okay, anytime we have an X equal to, that's a binomial PDF. We are looking for one value from that overall probability distribution function. Okay, so we want binom PDF. Our N is 30 people, our P is 14%, and our X in this case are those 5 people we are interested in. Okay. When you do that, you should get 0.177. Okay, 0.177. So I'm going to give you again an interpretation. I think it's good that we practice doing these interpretations, even if it doesn't say so in your note packet. I wrote the notes. I have the right to change it, correct? So this would mean that about 17.7% of the time, 5 out of every 30 Zyrtec users experience drowsiness. Okay, pretty much what that means in a nutshell. Okay, but don't just say 17.7% of the time 5 Zyrtec users experience drowsiness. 5 Zyrtec users? There's millions of Zyrtec users out there. Okay, so you do have to say 5 out of 30. Those details, yeah, they really do matter. All right, what is the probability that at least one person has experienced drowsiness? So at least one, again, we're looking at that idea of a minimum of 1. So we want the probability that X is greater than or equal to 1. 1, 2, 3, 4, all the way up to 30 people. Again, we're not going to do it that way, okay? That's way too many calculations. So what we want to find out is what are the scenarios or scenario that we don't want, okay? If at least one person gets tired, the only thing we're really not interested in is that nobody gets tired. So what we want to do is subtract the probability from 1 that X is 0, okay? Because 1 and above is what we're looking for. 0 is the only thing we're not interested in. So this is going to be 1 minus, and this is still, because it's now an equals, a binomial PDF. N is 30, probability of success is 14, and we're looking at 0 people being drowsy. And this gives us a value of 0.989. In other words, 98.9% of the time, at least one out of every 30 Zyrtec users will experience drowsiness. All right, last one. What is the probability fewer than 10, turn the pen on, fewer than 10 people have experienced drowsiness? So here we're looking for the probability that X is less than 10. Okay, X is less than 10. So this is not an equal to, okay, this is a less than. We're going in the right direction. We want to include 0, right? 0 up to how many people. So this is 0, or x equals 0 up to how many people qualify as less than 10 at most. I'm hoping you say 9. Okay, less than 10 does not include 10. So we want to figure out the probability that 0 to 9 people experience drowsiness. That is exactly what binomial CDF does. It starts at 0 and goes up to where you tell it to stop. So we've got 30 people in our trial, 14% chance that they get drowsy, and we want our calculator to add up that nobody gets drowsy all the way up to 9 total people get drowsy. And here you should come up with a result of 0.994. Okay, and again, we've got some really key points in each one of those scenarios. So please do take the time to look and make sure you understand when PDF is used, when CDF is used, why we didn't do CDF up to 10, why we stopped at 9, why we did the subtraction in B. Those are all good, important, very important details.